Hello everyone, this is Mr. H again, and welcome back to my YouTube channel. In this video, you will learn about graphing linear equations. But before we jump straight into the very first example, I recommend that you check out the previously uploaded videos about graphing linear equations. You can check out the link in the description box later. Alright, so let's take a look at the first example. Example 1. Graph each equation on the same coordinate plane. Alright, so for this question, I need you to remember one thing. If only x variable is present in an equation, definitely you will be expecting a vertical line graph. Alright, so let's talk about letter A first. So it says here, x equals 4. Alright, so definitely if you're gonna have multiple points on the grid, you will be looking at, for example, 4 comma 1. Another point will be 4 comma 7. Another point can be 4 comma negative 1, so on and so forth. So what do you observe from these points? So all the x coordinates are the same, because all these points that I wrote here, they lie on the same line, which is x equals 4. All right, so let's graph x equals 4. So this horizontal number line here is the x-axis, and the vertical number line here is the y-axis. And if you're gonna look at the x-axis, so 4 is here, and just simply draw the line, vertical line there, and that is the graph of x equals 4. So you can see 4 comma 1, this is 4 comma 1, that green point right there. So 4 comma 7 is here, and 4 comma negative 1 is here. All right, okay, so let's head on to letter B. If you want to try, you can pause the video and try to graph x equals negative 5/2. All right, so let's graph letter B. All right, so first of all, negative 5/2 is equal to negative 2.5. And negative 2.5 is here. Okay, and then you just draw vertical line there. All right, must be a straight line. Okay, so that is the graph of x equals to negative 5/2. All right, so if you like this example, give me a thumbs up. Let's head on to example number 2. Graph each equation on the same grid. This time, if you notice, the only variable that is present in each equation is y variable. If that happens, then you will be expecting a horizontal line graph on the grid. So for the first example earlier, the variable is x only, and the line graph is vertical line. And for this example, if y is the only variable, then the graph is a horizontal line. All right, so let's answer letter A. So we were given an equation 5y plus 10 equals 0. So just solve for y first. So 5y stays on the left-hand side, while positive 10 moves to the right. From positive, it will become negative. And to solve for y, we need to divide both sides by 5. So this is what we will be graphing. All right, so this time you will be looking at the y-axis, which is the vertical number line up here, and y equals -2. So it's a negative number, so -2 is here. And draw a horizontal line. All right, so that is the graph of y equals -2. Or you can write the original equation, which is 5y plus 10 equals 0. You can pause the video now and try to graph first letter B, y equals 0. Let's check your work. If you look at the vertical number line, 0 is here. This intersection of the x-axis and the y-axis is the origin, so that's 0, 0. So y equals 0 is here. So you can say that y equals 0 is the same as the x-axis. Let's head on to example number 3. All right, so we need to graph each equation on the same grid, but this time, if you notice, each equation has two variables now, right? So what does this tell us? If you see both variables x and y in one equation, definitely the line will be a slant line or diagonal line, okay? So it can be like this, can be like that, like this. All right, so let's take a look at 3a. So we were given an equation x plus 2y equals 4. So before you graph every equation that has two variables, what you need to do first is to rewrite each equation into the form of y equals mx plus b. This is what we call the slope-intercept form. All right, so rewriting each equation into slope-intercept form will definitely help you big time in graphing. So we'll have 2y stays on the left equals x will move to the right hand side, so from positive it will become -x. Positive 4 is already on the right hand side, so you don't change anything, just copy it. So to be able to find the final equation in slope-intercept form, we divide every single term by +2. So 2 divided by 2 is 1. You can just cancel that. And we're now left with y. So -x divided by 2, just copy. You can't do anything anymore with that. So plus 4 divided by 2 is 2. So this is the equation in slope-intercept form that we will be graphing. This is now the purpose of why we rewrite each equation to slope-intercept form. First, you have the y-intercept here, which is +2. So that is the very first point that we will plot on the grid. We call it the y-intercept. And y-intercept is found on the y-axis. All right, since the y-intercept here is +2, so that's the first point that we need to plot, and +2 is here. All right, so that's the very first point that you need to plot, because the other points will follow from that point. So after plotting the y-intercept, we will be using here the slope, the m, or the rise over the run. So the slope is the numerical coefficient of the x term here. The slope there is -1/2. So -1/2 tells you the direction that you need to go for, because you will be counting the units from the y-intercept. All right? So rise over run. So rise, either you go up or you go down from the y-intercept. You go up if the number is positive. You go down if the number is negative. And for the run, you go to the right if it's positive, and you go to the left if it's negative. So count -1 from the y-intercept, and -1 is 1 unit down the y-intercept. So here, and you stop there. Next, you need to count 2 units to the right from where we stopped. So this is the next point. If you want to continue to find the other points, then you can continue following, the trend, the counting. So 1 down, 2 right. So 1 down, 2 right. You can also do the opposite. So you can have 1 up, 2 to the left. So you just simply switch the directions you go for. So all of these points will lie on the same line. So you just simply connect the dots, and that will be our line. All right, so that is the line graph of the equation x plus 2y equals 4. Feel free to pause the video and graph letter B. If you notice that the equation is already written in slope-intercept form, so that means we can go graph straight away. So the first thing that we need to plot is -7. That's the y-intercept. All right, so I'm going to be using a different color for this line. So -7 is here. Y-intercept is at 0, -7. That's the -7 there. And the slope of the line is +3. So applying the rise over the run, so m is equal to 3. Therefore, rise is 3 and run is 1. 3 divided by 1 is 3. All right, so 3 up, 1 to the right. And you count from the y-intercept. So 3 units up, and then 1 to the right. Then we continue doing the same things. All right, so that is the graph of y equals 3x minus 7. If you find this video insightful, please give me a thumbs up. You can also share the video. And if you haven't subscribed yet to my channel, please do so. And you can also turn on the notification bell so that you won't miss any of my future videos. So once again, this is Mr. H, and thank you very much for staying until the end of the video, and I will see you in the next one.